Yes, we continue with the vector basis and analysis. Now, about the breakdown of vector basis, we are moving into what we call the unit vector and the standard unit vector and coordinate system. About that, we are going to carefully define what we call a unit vector. Now, when we say a unit vector in physics, what we are actually trying to say is a vector having units. Unit actually means having one magnitude and a specific what direction. Generally, we say unit vector is analyzed with this simple diagram for understanding sake. Now, if we have a vector of magnitude and direction, as discussed in our previous section, we have vector A, direction of theta, already discussed, and we can express this mathematically as a vector. We definitely have a magnitude of A and a direction of theta. So without wasting our time, if we do something now to get a unit value from here, what we do is just divide both sides by what? By its own magnitude. So doing that, we have a vector divided by A is equals to A over A, then direction of theta. A over A, everybody knows is going to give us 1. So a unit vector in physics, a unit vector is denoted as a vector divided by its own magnitude. Vector over its own magnitude is called unit vector. So in continuation to that, I can say we denote unit vector using what we call a cap. Please, students should be careful about the terminologies. They are very, very important. So a cap, which is the unit of this, a over a is 1, is a cap, is now equals to, this is vector, that is vector divided by its magnitude. Generally, you can also do cross multiplication if you are used to this formula by saying a vector is equals to a cap, which is the unit vector, multiplied by the magnitude. So anyhow you want to write the formula, but keep it in mind that unit vector is always in terms of what? Vector divided by its own magnitude. Nothing more, nothing less. Now, talking about the standard unit vector in coordinate system. That is another important thing we need to talk about. Now, if we talk about coordinate system, in vector representation, we talk about the XY plane and general XYZ plane. And generally, we have what we call the I, the J, and the K vector. Now, this is what I'm trying to talk about, dear students. Let's quickly look at by using a simple diagram to understand that. Let's look for a good one. Now, we have x-axis. I know many of us are used to X, Y, and Z. I'll just use an illustration which I use to explain everything once and for all. We have the y-axis. The y-axis is your vertical line, x-axis is horizontal, and maybe probably we can go with the third one, which is the z-axis, the z component. I know you guys have heard about all these things in your early classes. This is the the y-axis. Then my z-axis, let me just slant it a little bit, just for understanding sake. Now, early classes way, remember, this is x, this is y, and this is z. Now, talking about how we represent the unit vector in coordinate system, always have it at the back of your mind. And the x-axis vector we represent as I vector. Then the y-axis vector we represent as the j vector, which we write as j cap, I cap, and the z one we represent by the k vector, which we write as k cap. So you always keep that at the back of your mind that whenever we are representing any value in physics in terms of vector, which is in standard unit vector, we use the ij and the k vector. For example, if I write vector A now in this format, and I say A is equals to 3. So if you want to write it in standard unit vector, you said A vector here will be equals to 3r, and that will fall to this place. Now the same thing to j. I can say, let's say if b vector is equals to 2, So that means what I'm trying to say here is that B vector is same thing as writing it as standard unit vector. It will be 2j, j cap. So always keep that in mind. The cap is important. And if I want to do the Z one, I take that as C. I take as a 7, C vector, which is the third one, the resultant. Then in standard unit form, it's going to be C vector is given as 7k cap. So always be careful about this notation as you are going to what be talking about some calculation in that unit vector and the position vector of what standard unit vector. So in this slide, let me quickly talk about position vector using the standard unit vector, which is very, very important for us to understand. So we talk about position vector using the standard unit vector. So let's quickly talk about that. Position vector using the standard unit vector. So about that, my dear students, we can quickly just talk about, we've discussed position vector at the beginning of the slide. And under that, we talked about talking about the position of a particular vector with respect to its what? Reference point, which is always the source of origin. Remember that. Now, here, we just want to use that idea now with respect to the unit vector in coordinate system. Now, without any further ado, we can quickly say that we have very good. Now let's take a very good illustration to that. Let's say we have a position vector of p vector. That is our p vector. I hope students still remember that. This is our p vector as position vector with respect to p. I'm taking that as I'll take that as coordinate of 5 and 4. So I'm taking this as RP vector because that's the position vector with respect to the source of origin. We've talked about this. For those that are just joining us, we just need to watch one or two things. Now let's take another one, another reference from here to this point. Now, let me just take this one as let's try to draw a line. I just want it to be a broken line. I want you guys to understand. We take position vector from this point to this point. Let's join this one using a broken line, and we have this. So we are taking this particular one as let me just take it as RY what? RY vector. I'm just using an illustration to represent the position vector of this one. So now, from what I've explained, guys, remember, if we have this coordinate system, remember, your coordinate system is always x, y plane. Now, this will be x and this will be y. So representing something like this, we can quickly say that here, the 5 here stands for what? The I cap. And the 4 here is standing for the what? For the j cap. So we can represent this 5 in position what? According to unit vector as writing it as 5 I cap. Then the 5 y value here, we write it as what? 4 j cap. So writing down one here, we can put the illustration here like that. The position vector of ry vector is the same thing as, you can see the y coordinate here by writing it as 4 j cap. And the position vector of rp vector, which is the one that is acting like this on the x-axis. This is x-axis. You can see here, you can always keep that, which always equals to the 5y. So that is our 5I cap. So always remember that when you are representing coordinate system of the ijk vector, you can also do that in terms of your position vector with respect to the source of origin. And that is what I'm trying to let you know. And in xy plane, the I cap is the x, the j cap is the y, and the k cap is the z. So that's that about that. We can quickly take one example to understand this. And remember the way we've talking about if it is having an angle towards the positive x-axis, you can go by your Pythagoras theorem, and you can just say rx vector. Now rx is equals to, from what? It will be equals to rp. Rp is like what? Your hypotenuse here. Rp cos theta. And you can also say ry as position vector with respect to point y is the same thing as rp sine theta. What I've done here is what we've learned in the other example when I talk about a rectangular component of vector. So guys, that's about that. Always keep it at the back of your mind that it's quite simple to represent unit vector in what? in what? In XY plane using what? It's very easy to represent position vector using the standard unit vector to represent them. And again, we can always calculate the resultant. Please keep that at the back of your mind. We can always calculate the resultant of the vector. Now, the resultant of vector, which we call the magnitude of the two, is always given as, I know you guys might have heard about this. So resultant of these two vectors, which is the RP vector, I can say is equal to the square root of the first vector, that is 5 squared, just like Pythagoras theorem, plus 4 squared. You can always finish this to get the answer to that. So that is that about that, my dear students. Even if they are not just two, if it is X, Y, and Z plane, you can always get the value of the what? Of the what? Resultant vector by taking the square root of the sums of all the coordinates. And that is what we are going to face squarely in the next slide. So in this slide, I will stop here. I believe you understand representation and how to calculate each of them. Remember what I've explained here is that what this is Ry, and the one acting here, Ry is acting downward, Rx is acting here. So now the coordinate of Rx and Ry is what will give me the what? The Rp, which is what? The square root of what? The I cap and the j cap. So please keep that at the back of your mind, because we are going to look into some extensive, or let me say advanced question, which we are going to be talking about the position vector of one point with respect to another point in the next time, and we are going to take work example. So see you guys soon. You have a wonderful time. Bye for now.